Hi guys, welcome to Pre-Algebra with Miss Betsy. I'm still in Florida, but I'm going to begin Chapter 6 today, where we're going to be doing a lot of review about dealing with fractions. So let's go ahead and pray, listen to my lame question, and we'll get started with this material. Father, thank you for your goodness to us, and thank you for the opportunity to learn new things all of the time. Lord, I ask that you would help me today to be able to communicate things clearly to my listeners. I ask, Lord, that you would give them the ability to understand the material before them. And I pray all of this in the name of Jesus. Amen. Okay, this is a recycle lame question from middle school math, but tell me what it is that you get when you cross an automobile with a household animal. Well, when you cross those two, you end up with a carpet. You end up with a carpet on your floor. In section 6.1, we are simply going to be reviewing how we add and subtract rational numbers in various forms. And what are the rational numbers that we're going to be adding and subtracting mostly? It's mostly fractions. So, what do we do if we are adding and subtracting fractions with like denominators? How do we add or subtract fractions that have like denominators? You keep the denominator and you add the numerators. If we have 4/9 plus 7/9, same denominator, so we're going to add the numerators, and we have 11/9. Now, our text here says to go ahead and change this improper fraction to a mixed number. How do you change to a mixed number? You divide the numerator by the denominator, and you take your remainder. That remainder becomes the numerator of the fraction, and the divisor is your denominator. So you end up with 1 2/9. Let me go ahead and write a little note here. And I'm just simply going to say, to rename as a mixed number. That's too much, John Mark. To rename as a mixed number. That's where you're going to do your long division. And you take the divisor, you take the remainder, and that becomes the numerator of the fractional part of your mixed number. The divisor is the denominator. So this should be nothing more than pure review for you, 100% review. Now my personal preference is going to be, because this is a pre-algebra class, it's not a middle school math class, it's not an elementary class, is that you would go ahead and leave your fractions, your rational number, in reduced form as improper fractions. But again, be careful to look at the instructions. If they ask you to rename as a mixed number, go ahead and do that. Otherwise, just leave your answer as an improper fraction reduced to lowest terms. You're going to do the same thing if you're adding with what you're doing here, adding when you are subtracting. Let's go ahead and look at example B right here. We have 11/12 minus 3/12. 11/12 minus 3/12. When you add or subtract, as long as you have common denominators, you're going to add or subtract the numerators. So this becomes 11 minus 3. 11 minus 3 is 8, so we have 8/12. Is 8/12 our final answer acceptable as it is? No, it's not, because even though we have correctly subtracted these two fractions, we have not expressed that in lowest terms. So you must always reduce your final answer. Make sure that it is expressed in lowest terms. I'm out of space here at the bottom, so I'm going to say that 8/12 is equal to 2/3. And the reason for that is because there is a common factor of 4 that you can cancel. 2 times 4 is 8. 3 times 4 is 12. And you have been able to cancel that common factor of 4. 4 divided by 4 is equal to 1. When you multiply or divide by 1, you're not changing the value. So even though 2/3 and 8/12 look different from one another, they have the same value because you have simply reduced by an expression that is equivalent to 1. The only little hiccup in here is if you don't remember, if you're not careful and you end up with something strange like if we were adding here and you ended up with 11 plus 3 is 14, 12 plus 4 is equal to 24. No, you don't do anything with your denominators when you are adding or subtracting it once they have a common denominator. All right, let's go ahead and move on to page 221, and we're going to say, what do we do if we have unlike denominators? How do we add or subtract those fractions? Well, as I would expect, you have been reminded, if in fact you didn't already know this, in order to combine fractions with common denominators or with like denominators, you just add the numerators or subtract them if you're doing a subtraction problem. So that's all you have to do in order to add or subtract fractions that have different denominators, is rename those fractions so that they have a like denominator. So they have a common denominator, 5/8 plus 2/3, not 3/2. 5/8 plus 2/3. So you want to look at that and say, what is our common denominator going to be? We want it to be our least common denominator, because we could look at this and I can tell you that 240 is a common multiple of 8 and of 30, but it would not be particularly helpful for us to rename these fractions here with the denominator of 240 because the numbers are getting too large. So what we want to do is actually use the least common multiple. Use the least common multiple. Now, I'm not going to take time to reteach how you find the least common multiple. We've talked about that a lot on more than one of my videos. There are videos where I spend a lot of time simply teaching how to do the least common multiple. If you're watching this video and you don't know how to figure out the least common multiple and you want to see one from me and you're not in my co-op classes, send me a message through YouTube and I'll help you get connected to those least common multiple videos. But the least common multiple here is going to be 24. So we're going to need to rename 5/8 with a denominator of 24 and 2/3 with a denominator of 24. So we're going to multiply 5/8 by 3/3. We're just multiplying by a form of 1. We're not changing its value, but we are changing its form. Because when you multiply by 1, you don't change its value. That's that multiplicative property of identity. 2/3 we're going to multiply by 8/8. So we have 2/3 times 8/8. And when we complete that multiplication, we are able to add our numerators together because we have now common denominators. We end up with 31/24. 31 is a prime number. So this improper fraction here is reduced to lowest terms. Now if you're looking at BJU Press's Pre-Algebra book on page 221, they go ahead and take this to a mixed number of 1 and 7/24. This is perfectly acceptable. at this point. Now, example number 3, we're subtracting two fractions that have different denominators. This is example 3. And we are told simply subtract 7/10 minus 4/15. Same thing. If you have unlike denominators and you are adding or subtracting, you have to rename these fractions with a common denominator. It's going to be your LCM. Again, if you need help determining what the least common multiple is, text me if you're in my class, or put a comment on the YouTube video if you're not, and I'll help you out. A common denominator here is 30. We're going to multiply 7/10 by 3/3. And we are going to multiply 4/15 by 2/2. It doesn't matter at all that we're multiplying by different values here, because as long as your numerator and denominator are the same, you're just multiplying by a form of 1 and you're not changing the value. You're simply changing the appearance of these fractions. So you now have 21/30 minus 8/30. When you complete that subtraction, you see that 7/10 minus 4/15 is equal to 13/30. Again, 13 is prime, so there's no further reduction that you need to do, no further simplification of this rational number here because it's in lowest terms. Now, where pre-algebra addition and subtraction of fractions or of rational numbers differs from the addition and subtraction of rational numbers in middle school math or in the lower level math, elementary math, is that you guys in pre-algebra are familiar with the concept of negative numbers, and rational numbers or fractions can be negative as well as positive, and you're going to add and subtract negative rational numbers just the same way that you add and subtract integers, which would be positive or negatively signed numbers plus 0. Something that we want to review quickly is you recognize this expression right here as negative 5/6. This can also be expressed as a negative 5 divided by 6, and it can also be expressed as 5 divided by a negative 6. So all three of these forms of negative rational numbers are equivalent. Now, our text tells us that the form with the negative sign in the numerator is the most useful for adding or subtracting rational numbers. And I think the more that you are accustomed to adding and subtracting negatively signed fractions, the more comfortable you'll get with it. You won't even need to be careful about where you identify, where you place that negative sign. So I want you to go ahead and remind yourself how you find the sum of two rational numbers. Obviously, I would hope it would be obvious that if you are adding together two random rational numbers that have the same sign, the sign is going to remain the same. If you have a positive 2 plus a positive 7, your answer is going to be a positive 9. You have a positive 2/3 plus a positive 4/6. Your answer is going to be positive. As long as the signs are the same, when you're adding two rational numbers together, the sign of the answer is the same as the sign of the individual numbers that are being added together. So the sum of two rational numbers with the same signs are going to keep that same sign. Sum of two positive numbers is positive, Sum of two negative numbers is negative. And if you have differently signed numbers, do you remember how to do this? It's a slightly technical definition. If you want to find the sum of two numbers that have different signs, you have a positive number and you're going to add a negative number. How do you determine what that sign is? Well, you subtract their absolute values and you use the sign of the number that has a larger absolute value. That becomes the sign of the rational number. Let me go ahead and write this down for you. First, you're going to subtract absolute values. And what are the absolute values going to be? Doesn't matter if you've got a negative rational number or a positive rational number. Their absolute values are going to be positive because absolute value is positive. Now, how are you going to determine what sign to use in your answer? What sign for the sum? Remember, we are adding oppositely signed numbers. So what sign are we going to use for the sum? We're going to use the sign of the rational number with the larger absolute value. I'm going to take the time to write this out. Sign of the larger, sign of the rational number with the larger absolute value. It is so awkward writing down here low. Sign of the rational number absolute value. I really miss my large board at home in my dining room. Absolute value. How do we add oppositely signed numbers? We subtract their absolute values and we use the sign of the rational number with the larger absolute value. We take the sign of the number that looks larger to us if we ignore the sign. Now that is just makes math people crazy to say the number that's bigger, because it's not when it's a negative number. But if you look at the number, ignore the sign, take the sign of the number that is going to sort of look larger to you. If you're stuck with that, send me a text and I'll help you out. But that should not be a problem for you. So we are now on page 222 and we're having some practice here of adding together fractions that have different signs. We have negative 5/8 plus 1/5. So in order to solve this problem, again, you have to go through the step of finding the least common multiple, which is going to be 40, and renaming these fractions so that they have a denominator of 40. And of course, we have negative 5/8. We're going to multiply by 5/5. We have 1/5, and we're going to multiply by 8/8 so that we are able to come up with a common denominator of 40. We have negative 25/40 plus 8/40. We have our common denominator. Negative 25 plus 8 is negative 17/40. If you wish to rename that, if you wish to rewrite this so that you have that negative sign in front of the entire fraction, that's fine. But these have equivalent meanings, so I'm perfectly happy for you to show your answers negative 17 divided by 40, or negative 17 whoops, negative 17/20 is not the answer that I was looking for. Negative 17/40 or 17 divided by a negative 40. Any of those numbers are perfectly acceptable. Let's go ahead and look now at example 5. We have negative 2/3 minus 1/9. If you have this text, you are on page 222. So if you're in my class, you can very easily follow along with these. We have example number 5. We're subtracting. We have negative 2/3 minus 1/9. Common denominator is 9, so we end up with negative 6/9 minus 1/9. The more that you practice with subtracting signed numbers, the more natural it is going to become for you to look at this and notice that this is negative 7/9. But until you're really comfortable with this, you can always remember that subtraction can be expressed as adding the opposite. Subtraction is the same as adding the opposite. And why do we convert from subtraction into adding the opposite? That's because we know how to add oppositely signed numbers. So we have a negative 6 plus a negative 1 in the numerator. All of that is written with our common denominator of 9, gives us the negative 7/9. Remember I said, as you deal with adding negatively signed, as you deal with subtracting positive and negative numbers, you're going to easily go to say negative 6 minus 1 is a negative 7/9. Only add this step if it's necessary or helpful. Add this step if it's helpful. If you don't need it, you do not have to change subtraction problems so that you're showing them as the addition of the opposite. All right. We have now negative 11/12 plus 3/4. It's really the same problem. They're just wanting to make sure that you have plenty of examples of how you add oppositely signed rational numbers or how you subtract them. We have example number 6, and we're going to add negative 11/12 plus 3/4. Rename these with a common denominator of 12 by finding the least common multiple if you need to, multiplying numerator and denominator of here by 3, you end up with a negative 11/12 plus 9/12. Negative 11 plus 9 is a negative 2 over 12. You have to reduce to lowest terms. Negative 2 over 12 is the same as negative 1/6. Has to be reduced to lowest terms. I'm not spending a whole lot of time because this really is review. If you are still struggling, make sure that you get some help. Text me or look at Khan Academy. Struggling? Boy, I can't write neatly here. Make sure that you are comfortable with fractions. You have to be. Con, let me pull this over here so that I can write it. Khan Academy www.khanacademy.org. www.khanacademy.org is an excellent resource to help you with fractions. All right, what about if we are adding or subtracting mixed numbers? Again, this is review, making certain that you have not forgotten how to do this as you've moved into middle school math. What do you do when you add or subtract mixed numbers? Well, you add the whole number parts and you add the fractional parts separately. If we have 1 5/6 plus 4 4/9. When you're adding or subtracting mixed numbers, it's best to do those vertically. So you have 1 5/6 plus 4 4/9. Add your whole number parts, add your fractional parts. However, we can't because we have 5/6 and we have 4/9. We have to rename the fractional part here with the common denominator. So let's go ahead and do that. What's our common denominator going to be? Common denominator 6 and 9 is 18. So this becomes 1 15/18 plus 4 8/18. Make certain that you understand how I got that. Now we're going to add the whole number portions. 1 plus 4 is 5. And now we add the numerators of our fractional portions and keep that same denominator. 15 plus 8 is 23 over 18. Are we finished at this point? Nope. I got an answer like this on a test recently. When you have a mixed number, that fractional part cannot be an improper fraction. You have to rename this fractional part here as a mixed number and then combine the two. What do I mean? Well, that's actually 5 plus 1 plus 5/18. 23/18 is the same as 1 5/18. 5 plus 1 is 6, and 5/18 is the sum of these two mixed numbers. So when you're adding mixed numbers, you have several things going on. You have to make sure that you rename the fractional parts with the appropriate common denominator, add the fractional parts once you have renamed them, and then if you end up with an improper fraction here, make sure that you adjust your answer so that you have your mixed number in proper form. A mixed number in proper form is going to have a whole number part, and then it's going to have the fractional part, which has to be, number one, a proper fraction, and number two, it has to be reduced to lowest terms. So be careful with that. And then make sure that you also are remembering how to subtract, not subtract, to subtract mixed numbers. And you've got a little bit more going on when you subtract mixed numbers because you frequently are going to have to borrow. So we're going to look at example 8 here. We're going to subtract 5 1/4. Well, we're going to subtract from 5 1/4 2 3/8. And I just went ahead and changed that into our vertical form here because with mixed numbers, when you add or subtract, it's definitely to your advantage to set it up vertically. Cannot subtract these yet because our denominators here are different. So first we're going to rewrite 1/4 as 2/8 because we have a common denominator of 8. Now we have 5 2/8 minus 2 3/8. You can't do that because you have to subtract 3 from 2. So you're going to have to borrow 1 from the 5, but you're going to borrow that in the form of 8s. So this is going to become, let me actually go ahead and write this in here for you, just in case it's a helpful reminder, that is going to be 4 plus 8 over 8 plus 2 over 8. And we still have 2 3/8 here. Let's look at this real briefly and make sure that you've got it down. Five is the same as 4 plus 1. But we need to borrow that 1 in fractional form, so we rename it as 8 over 8. Then we end up with, bring our problem down here, we end up with 4 and 10/8, and from that we are subtracting 2 and 3/8. This is how we have to rename 5 and 2/8 becomes 4 and 10/8 so that we can carry out that subtraction. Now we can subtract the whole number parts and we can subtract the fractional parts. Subtracting mixed numbers where you need to borrow, that's where most people, if anyone's going to be prone to have difficulty when you're dealing with adding and subtracting fractions or mixed numbers, it's when you subtract mixed numbers where you need to borrow. So study this example really well. Make sure that you understand how to subtract mixed numbers when you have to borrow. Text me for help or send me a message through YouTube. All right? The last thing that I'm just going to point out for you is a brief review of subtracting decimal numbers. Subtracting decimal numbers is no different in actual practice from subtracting whole numbers. The kicker here is that you have to make certain to align your decimal points. So if you're going to add or subtract decimals, what do you need to make sure that you do? You need to make certain that you align the decimal points. That's your secret key here. Align the decimal points. If you do not align your decimal points, you've got a problem. So if we're going to add 42.678 plus 8.34, and our final add-in here is 127.6. And we're not punching this into our calculator. How are we going to do this? We're saying 42, and I'm not sure where that 14 came from. We have 42.678. We're adding 8.34, and we're adding 127.6. Okay, guys that are in my ARCHE Pre-Algebra class, I know I've said you can use your calculators. Make certain that you understand how to do this by hand, because it's lost on you to simply punch those numbers into your calculator. Just make sure that you remember when you're doing calculations by hand, because there will be times that you have to hand calculate. Make sure that when you're adding or subtracting that you line up those decimal points. And the answer here would be 178 and 618 thousandths. That's your key. If you're going to add or subtract decimal points, add or subtract decimal numbers, you make certain that you align the decimal points. And that's the end of a rather long section, 6.1, where you're dealing with the addition and subtraction of rational numbers in various forms, but it's all review. I've got total confidence that you guys will have no difficulty with it. If you do, however, don't hesitate to text me, and I'll see you next time.